Yeah.
So you only have once, just go for it.
Ooh.
That's the reaction you want. Today we have something slightly different, and it involves me being back on a machine. Now, as you know, I used to be a machinist, so this is going to be fun. So let's see what happens. Now, I've had a part I've been wanting to make for a while, and the guys here at MSC have been ever so kind to allow me to use their tech centre. But on two conditions. One, I have to use their new Edge range of tooling, and two, I have to give them a brutally honest feedback on if it's any good. Now, I was a machinist for 10 years, and I've used some top of the range tooling down to tooling that should have never been made. So it's going to be interesting to find out if it's any good, and if it's not, I'm going to tell you it's crap, or if it's worth it. So let's head into the tech centre, and I think they're ready for us. Well, Kazra, we're finally here. Thank you for letting me use your Hurcos. Quite familiar there, so that's going to be good.
Yeah.
I just wanted to show you my program before we get up and running to see if what I've done, you think your tools can handle it. Now, I programmed this off of your book data, which is quite aggressive, I have to admit. But I've actually got two of these parts to run, so I'm going to run one at your book data, but then one at my own data, which I'm not going to tell you about. Now, do you think what I've done, your tools will get through it?
Absolutely. If you've run it based on our book data, definitely. And we've pushed it even further than that, so I'm pretty confident that it'll do it, yeah.
Now, I'm looking forward to this, and let's be honest, if it doesn't work, we're going to be completely honest here. If it doesn't work, then we're going to see some broken tools, but with your attitude and experience, I'm looking forward to this. So I think the next best thing, let's get the camera gear set up and let's get rolling.
Yeah, absolutely. Let's do it.
So, Kazra, while I was setting these tools up, I was flicking through your book and saw the highlights page. Now, what does all this actually mean for a customer from you, as you are the expert in
Yeah, so as I was explaining to you, we have actually designed these tools in-house. So we've got quite a lot of application engineers dotted around the country looking after our customers. And based on the customer applications, we came up with this tool, but it wasn't the first iteration, this final product. We actually had to go through lots and lots of testing. So when we say, for example, we've got variable pitch and variable helix, that means we started with a non-variable pitch and non-variable helix variant, and then we tested it and we saw that you get chatter, you get vibration, so we added that, we added the corner protection, we went through a few versions of coating, and we found that this coating protects the tool better than anyone else's tool out in the market. And also, when it comes to our drills, again, we've got 5 times the with through coolant, 3 times the without through coolant, because we saw that you don't really need through coolant in 3 times the. So that's why we've got only the 5 times the with through coolant.
But there's so many M mills on the market already. Why did you decide to make your own?
So it's actually a good story, because we saw that a lot of the tools out there in the market are quite specific for a single application, and we wanted to help our customers to rationalize their tooling in the carousel. So we came up with this idea that you can pretty much do 80% of the jobs with only 20% of the tools, and that's why we created this range. So it's a relatively limited range, but you can do a lot with these ranges.
Now, I'm going to finish loading these tools, and I think it's time we actually get the machine running.
Yeah, let's go.
Chris, are you ready? Everything running? A little bit nervous about this, but anyway. So, start off, it's just going to probe, so at least that should be all right. Everything on. I think I've zeroed everything, yeah. Oh, this takes me back. This is great fun. Whoa. So, I just want to make this crystal clear before we start. For 90% of this program, I'm not using coolant. Now, if I was doing this properly, I would be using coolant, but if I use coolant, you guys are not going to see anything, and I want you to see what I'm seeing. Right, put some air on. Look at that, both ways as well, not messing around here. I maybe could have had the pass extension a little bit shorter, but now a lot of people say, why am I not using a face mill? And that's Kazra's fault. So Kazra got me all the tools and he forgot to give me a face mill, so we're seeing what a 16mm edge will do as a face mill. And at the moment it looks quite nice. Right, this is where we get a bit spicy. Let's see how good this end mill is, shall we? There we go. So this is running on book data, but I've just had to put the spindle speed up slightly to stop it vibrating. Which I reckon this has got more to give, but we'll not do that yet. It's nice having a big screen, I get to see it, I guess I can actually see it. But, so I've added 10% on the spindle speed compared to the book data, just to get rid of that vibration. And that looks quite, that sounds really nice, actually. So now it's just gonna cut the two sides out. Oh, I went a bit hot. Right, I'll let that go in at full. Right, now, I'm quite nervous about this, so now we're going to helix in to take this middle pocket out. Slow it back down to book data just to see what it does on the oh my god, it's silent. You can hardly hear it. Again, I think another 10% on spindle will make that even quieter, but we'll leave it for now. We'll wait till it starts pocketing, see what it does. And let's not forget, this is actually H13, so it's not even just mild steel. It's not the toughest material, but it's not soft either. So this should get to the bottom and then interpolate out into a pocket. How far we got to go? Not far. There we go. So that's just stepping out at 10% where it was 15% on the outside, but I didn't want to leave too much swarf in the pocket. Oh, easy. Easy. What's this doing now? Oh, so now it's doing the outer pocket. Them chips are coming off a nice golden colour. What you'd want. Sounds quite stable. Ah, what are you doing? Don't do things like that without me knowing. Right, what's next? Drill. So for this one, I'm going to have to use coolant, I'm afraid. So I've got through coolant and flood coolant on for this, just because, oh, I hate carbide drills. Straight in. God, you can't even hear it. Straight through, one go, no pecking, no spot drill, straight in. Do you want the real answer or the non-real answer? The non-real answer is it's awesome. The real answer is I'm scared to bits, but it's great because it's doing it at the moment. It's doing absolutely everything I've asked of it. The bug data is quite aggressive. It's been on the drill, but with the sound of everything, I think it's got more to give. I really do think it's got more to give. But we'll try that. We'll try that after. Ooh. Trying to act quite cool. Normally my face would be implanted in that window. Trying to act like I'm not as nervous as I am. But
you could watch the big screen instead.
I know. Right, so we're cruising here. Here we go. We'll clean the windows so everyone can see, and then we'll go back to air only. Right, here we go. Yeah, I think that's got a lot more to give as well, because you can barely hear it. Colour of that swarf's coming off beautiful as well. Look at the big screen. Coming off absolutely golden. So that noise there was just swarf stuck in the bottom of the hole. Yeah, can't quite get right in there to get it out. Coolant would have done, but you'll not see anything with coolant. That's quite a big cut as well. It's quite a deep pocket. That's really nice. It's really nice. See, that one was nice. It got rid of all the swarf out the hole. I think I might be brave. On the next one I'll turn the air off and see what it does without the air on. Here we go. Let's listen to it now. Definitely got more to give. Nice. Chips are coming off a lovely colour. You know what? I've used a lot of end mills in my time that would not have done that. I would have really struggled with that. That's quite a small pocket, quite a big end mill, to have the room to get the swarf out as well. The chip evacuation is beautiful. I want to see just how much I can push them. You know what, it's lovely. It's so nice to be back on a machine. And obviously, being on a Hurco is quite an advantage for me, as I ran. For anyone who doesn't know, I ran Hurcos for, what, probably 5-6 years before I joined MTD, so I sort of know my way around the control a little bit. Now the difference is this was programmed on Fusion 360. If I was to do this again, I'll program it all on the machine through the conversational, because I just think if I'd have programmed it on the machine, I'd have a bit more control instead of going back and forth to the cam system. But there's also things in cam you can't do on the machine, so it swings and roundabouts. But again, I do have to, I would just like to say quickly, thank you to the guys here at MSC, because let's be honest, it's quite, you've got to put quite a lot of trust in someone to go, here's a machine, and as you can see, there's literally nobody around. We have the tech centre to ourselves. So it's not even like I've got someone over my shoulder. Kazra was kind enough to help me get the machine set up, got me the tools, and then he's just ran away. So it's quite a lot of trust to do that, and I would just like to say thank you to him for that. Hope I'm doing him justice. Like I said, it's quite nerve-wracking, especially using somebody else's machine, but it's also good fun. What are you doing now? Oh, so again on this section, I don't have a face mill. So obviously you saw me face mill it with a 16 mil, but then I've done quite a lot of roughing out with the same 16 mil. So we've just dropped the 10 mil in, just to finish across the top to get a nice finish, and really to see how nice of a finish you can get with an M mill. Like I'm not doing a 5 or 10% step over here, it's 75% there, so it's using quite a lot of the M mill in one go. And I think, as you can see just on that screen, it's quite nice, but once it's done, we'll have a look at just how nice it actually is. I don't think there's much more to go. I think there's we've got to put the rads on we've got to put the rad on the bore and the 2 holes in the centre, and then some chamfers, and that'd be op 10 done. And then op 20, that's quite an aggressive program to remove the back, because again I don't have a face mill, so trying to remove the whole lip at the bottom in one go with a 16 mil. So we'll see how it deals with that. It might work, it might not, I don't know. Again, I've not used these tools before. I don't know if these are going to work, or if with the strategies I've used, some M mills would work, some M mills won't work. So there's quite a few different pieces to this program. There's quite a few different operations, so we've got quite a few different M mills to try and make it work. And it's one of them, you go with what you've got. I've got the Edge range, so I've only got M mills and drills. I've got no face mills, no eye feeds, nothing like that. So I've had to design the program around the tools I got, and please don't have a go at me for my program, which I'm guessing some people will. Some people will tell me I've done it wrong, but there's a saying I always like, and if you give 5 machinists the same part, they'll all get the same finished part, but they'll all make it different. Let's be honest, I'm back on a machine. It's all about having some fun, more than anything else. So there is a really scary bit of this program in a minute, where the bore is like a stepped bore that goes down then goes in. I've even chamfered the inside of that, and it's quite close. But be brave or go home. It's one of them, innit? I don't like filing, I don't like bench work. So as much as I can do on here, the better. I think in the end I managed to get everything done on here. And I would say we're done. So let's have a look, shall we? I'll tell you what, Chris, wherever you've gone, I'll set that finish. That's not bad, is it? Say it's been done with an M mill, that's a lovely finish. You know what's nice, you can't feel, there's no tool marks, you can't feel any tool marks between the passes, which is always good. Let's get this cleaned, we'll get it back in, and then we'll come back. Yeah? Right.
Hey Tom, how'd it go?
Well, I've made one.
Yeah, brilliant. Look at that.
Tell me what you think.
Think of beauty. Yeah, looks really nice.
Something I do want to show you.
Yeah.
Look at the colour.
Ah, did you run that dry?
Yeah, I did.
Yeah, look at them chips.
And that was at book data.
Yeah, was it?
Yeah,
Right, okay.
so the thing was, when I first programmed it, I thought the book data looked quite aggressive. But then once it was actually running, it was quite a nice starting point.
Yeah.
Now, actually running that and seeing and listening, I feel like there's a lot more to give, which is what I'm going to do next. But the only slight problem I had was with when I did the 16mm, because you didn't give me a face mill.
Yeah, well, we don't have a face mill in the Edge range, but watch the space because, you know, we are expanding and extending the range all the time.
Well, that would be nice, but obviously I didn't have a face mill today, so I used a 16mm as a face mill. It's quite aggressive on the step over, and it vibrated just a little bit, but on the control, I just knocked the speed up 10%. It took all the vibration out.
Yeah.
And I think you can see by the finish as well.
Yeah, yeah,
Do you know what? It's really impressed me though, because I've used the same tool, not just the rough. So I've used the same tool to rough the pockets, but also finish the outside.
Right, okay. Yeah, it's a
And
nice
obviously
finish,
that's,
yeah.
you'd get quite a lot of people using a roughing cutter and a finishing cutter.
Yeah.
So that has been able to, I've been able to bring that down to one tool, and I don't think you can complain.
No, no. I mean, that's the whole mindset about Edge, you know, doing more with less tools, you know. It's the 80-20 rule that we call it. So you want to do more roughing and finishing with the same tool that's already in the carousel. It prevents more tool changes.
Well, if you like that one, stick around because I'm going to make another one, but with my data.
Right, let's check it out.
Right then, Kazra, we're off. Are you as nervous as me?
I am a bit nervous.
Well, I've gone for it straight away.
That's 100%.
That's 100%.
What are you thinking could happen at these speeds?
I would give it, 5%.
Yeah.
Yeah, that sounds a bit better.
Oh, there you go. You can't even hear it.
That's nice.
So another 10% on speed. You can't even hear it. Look at that.
Yeah.
So that's
pretty good.
whew, that's what?
180 meters you were running?
Yeah.
Yeah. With 0.2 feet to 2. Yeah.
Which is that sounds. Do you know what? That sounds really nice. Really nice. But you know it's going to be the next bit. That's the scary bit, don't you?
Yeah. Are you doing adaptive on the next one?
Yep.
Yeah.
So fair play. It did that pretty well.
Yeah.
I'll leave it up at 110% just because it sounded quite nice. Can always change it. There we go.
Fine.
That's
That sounds amazing, that does.
so that I've actually upped it another 15% on what I upped it before.
Right, you're running at 115% feed.
Yeah.
Yeah.
Look at that.
Look at the size of them straws. Wow.
I told you that tool had got more to give. I think it's got more to give again. You know what? You only live once.
125%. So you're running nearly 3 times faster than
The book
your
data.
first one, yeah.
So 3 times faster than the book data. That's pulling a bit of spindle load now though.
Yeah.
Still not much though. What? 18% spindle load. And that's still doing 15% step over,
Yeah.
but 125% on the feed. So what's that? 3,600 feet.
On H13 cutting dry with a 16mm cutter. Yeah.
Tell you only once, just go for it.
Yeah. No wonder you're no longer a machinist.
I tell you, I used to get jobs done quickly. Right, this is where I'm nervous now. It's still going to feed in though. That should feed in nice for that.
Yeah, just open it up.
I like how you've got more confidence than I have. What do you reckon?
You're only pulling 3% from the spindle. That's fine. Yeah, just leave it.
Yeah, it's when it gets to the bottom now, though, isn't it?
Yeah.
Look at that. Look at that.
Yeah, it's beautiful, that is. Yeah.
Do you know what? I would say that like little, it's like that bubbling effect of
Yeah.
the swarf. It's
Yeah.
getting all the swarf out,
Yeah.
which means it's not recutting its own chips.
Yeah. Well, that's the pitch. You know, that's the pitch that we designed in the tool.
Yeah.
So it's evacuating the swarf very nice, especially when you go into like a deep pocket. Yeah.
Look at the colour though. Absolutely golden. And do you know what? That's where I think that set's right, because they come out golden and they turn purple when they hit the bed.
Yeah. Well, that's what you want, you know, heat in the swarf, not in the part, not
Exactly.
in the cutter.
So it'll not warp the part because there's no. And again, if we were doing this properly, what's that? 100 and 110%.
Yeah.
Look at the.
You're feeding at 2,000.
Look at the swarf coming out. %. So over 2,000 feet.
2,400, yeah.
Whew. Oh, it's just picking the edge off now, isn't it? And then, right.
Is that it for that tool?
What do you think?
Beautiful. It worked.
It did work, and it worked
Yeah.
very well, didn't it? Right, so we've upped the speed on this as well, which is. So I'm just going to go for it, because obviously you don't mess about with
you
a
don't
carbide
want to be
drill.
messed about. No,
Don't mess about.
you can't hear it.
There's no noise.
Yeah, you're pulling some. Yeah, you're pulling like 7%. Yeah.
7% with a 10
Yeah,
mil
well,
drill.
you can't hear it.
No.
Yeah.
What? That's exactly what you want.
Yep.
You can't hear it. So if you can't hear it, there's going to be no
Yeah.
no explosion. But that's still feeding in at 400. So it's not hanging around in H13 as well. It's
Yeah.
not hanging around. Now obviously we're not going to be able to show anything here because, well, if you can see more on there.
Yeah. On the rotoclear camera, yeah.
You can see more
what
on
they've
there.
done.
But obviously that's the first drill, and then I just need to turn the through spindle off for the second drill. So again, watching that screen, absolutely dead silent.
Yeah.
That's just unreal, absolutely unreal. I've used quite a few carbide drills, and I know you have, and to get it to run silent
Yes. Yeah.
is, you normally at least hear it chipping.
No, it's absolutely silent.
Not going to argue with that. Oh no. Right, we're going to run this one with the coolant.
What tool is that one?
So this is the 2 flute.
Ah, okay.
So this is
Yeah.
going to plunge in and then slow.
Right. Yeah. So using it basically as a flat bottom drill.
Exactly.
Yeah.
Like I said. Oh, quick, put that up.
Yeah. Put that up to 100%. Yeah.
Right. So then that, like I said, running coolant on that. It's only a 2 flute. If any chips get stuck in there at all, it'll either chip it or snap it. So I think let's be safe. So you can hear it, but it's still there's no vibration in there. It's a
No.
nice cut sound. And let's be honest, every time you plunge, it's never a nice noise anyway,
No.
is it? You can never get a plunge to just be quiet.
But you're only pulling 1% from the tool, from the spindle. I mean, it's nothing. It's plunging now, you can hear it. And it's moving.
Like I said, it's not even registering.
No.
There's absolutely no register of spindle load. And as it's plunging, all the force is going up the spindle as well.
Yep.
So you would expect to see something,
yeah.
but nothing. Right then. Right, we'll clean the windows so Chris and everybody at home can actually see. So if I've got a question for you while I'm cleaning the window.
Yeah.
If I'd have told you that I'd run that 16 mil at that speed and feed and you hadn't seen it, would you have believed me?
I haven't seen it running at that data in H13, but we've done similar things in EN24T and D2. I've never done it in H13, so I have confidence in these M mills. Yeah,
I'm glad you have.
yeah. Well, it's your first time seeing it, you
Oh,
know,
is it?
but we've developed it here in this place, so.
Well,
yeah.
that's it. So you must have run this tool at all sorts of speeds and
absolutely.
feeds in all
Absolutely.
different types of
Yeah,
material.
Yeah. That book data has come from our experience on different materials.
So, on this tool though, I haven't upped the speed and feed in the program. I'm going to do that while I'm studying, just because obviously it's a smaller tool in a very small hole.
You maxed it out now, 150% there.
Yeah, so I've maxed the feed out. This the nervous bit will when it drops in though, because I don't want to keep changing it
Yeah.
after.
Ooh. You're recutting swarf there.
Yeah. So
Yeah.
that's not actually the tool. That was just recutting the swarf it couldn't
Yeah,
get out.
yeah.
Did anybody else see his reaction then? So maybe.
Maybe drop it down for the next ones, I would say.
You know what? No, I'm going to leave it for the first cut. Look at that.
Yeah.
And I'll drop it down for the second cut.
Okay. Yeah, when you're plunging in that one.
Yeah. It just couldn't get the swarf out of the
Yeah.
way quick enough.
I mean, your feed is 2,500 nearly.
Right, so I'll drop it back down until it gets going. Oh, I went down too far then.
Yeah, it sounded better now.
So that's 150% feed.
Yeah.
So we've done an extra 50% and an extra
You're hitting-
15 on the spindle.
You're nearly hitting 3,000 there on the feed. Brilliant. And that's a
Hey, we're not
10
messing-
mil cutter, yeah?
We're not
Yeah.
messing around. Right, I'm going to leave this at 150 for the first cut. Look at that. Sounds lovely. I'm just going to try.
You barely notice the difference, really.
Right, I will drop it though. So it just 2,781 feet
Yeah.
in a small pocket as well. Right, are we brave?
Look at that.
There you go. 150% feed, 150% spindle. I'll tell you what, if nothing else, I bet we've dropped this cycle time down quite a bit.
Yeah.
Just a swarf in the bottom.
Yeah.
Back up at 150, 150. Now have you run that tool like that? You can't even hear it though, it actually sounds better.
Yeah,
You can
yeah.
hardly hear it. Right. So now it's going to do, here we go.
Ramping.
So that's 150, 150.
Wow, look at that.
That's the reaction you want.
Yeah.
2,000,
Yeah,
2,600,
2,600,
yeah.
500, yeah.
no coolant, just there.
Yeah. What are you doing after that? Oh, is it you're finishing now?
Yeah. So what I'm going to do, I'm going to leave the finish pass at 150, 150, and what we'll do, we'll compare the finishes
Yeah, with the first one.
between the first one.
Fair enough.
Because the thing is, yes, I've upped the feed 150%, but I've also upped the speed 150% to hopefully
Yeah.
match that. But you do, well, I don't know, I normally did slow my feed down for a finish pass.
You
but,
usually do a little bit, yeah.
But we'll see what the difference is between them. We've got the two, we can compare.
Yeah.
From here,
And you haven't changed the tool
no,
from
no,
the first one,
no,
so
the
it's
same
the same
tool,
tool.
same tool.
Yeah, so you've already done one part with it. Yeah.
Same tool.
I'm finishing the pockets.
See, even that, how quick it's finishing them pockets now though. But the swarf is That's a lovely silver colour. There's no heat in that at all. And I think I left 0.3 in them. So it's not like it's just taking a skim off, it's actually taking a bit of material off.
Yeah, yeah.
So now it should finish the boards. And now it's going to finish the top.
Yeah.
So again, at 150, 150, we'll be able to compare between the first one and the second one
Yeah, yeah.
to see.
Any difference in the finish, yeah.
But even that, so we've got that up at 150, we can't physically go any further on the machine.
No.
The machine's maxed out on override controls, and I still think there's more to give in that tool.
Yeah, probably on the finishing side, yeah, you
Yeah.
probably can do, yeah.
I think the 16 we were getting close to.
Yeah. I think maybe a bit more.
I reckon we can give more.
We've ran it faster in D2, and
Yeah.
D2 is probably a bit tougher than that.
See, I think, yeah, it's definitely more to give on him. Definitely more to give. I'd be surprised to see if a lot of people would run it that quick in their normal job shop.
Yeah.
I think I'm definitely leaning towards this tool being a higher end tool at them sorts of speeds and feeds.
Well, that's the thing, you know, it's got an amazing cost per minute. So the tools are very, very fair priced.
Yeah.
You know, they're not up there in terms of price, but you can see the performance is quite up there.
I think we're definitely trying to showcase how good that tool was, especially with them speeds and feeds. Right, so what we got now? I think we've got the ball nose.
Yeah. The full flutes, ball nose, yeah.
Just to put the rads in.
Yeah.
And again, I'm just going to leave this. I'm going to leave it 150, 150. Like I said, that's still quite a. And again, I think
you've maxed out the spindle there.
yes,
So 12,000.
12,000
basically.
RPM. The spindle is max. The spindle can't go anymore.
Yeah.
And just shy of 6,000
Speed, yeah.
Speed.
Yeah, yeah.
is, and I think you can just see how quick it's running.
Yeah.
And again, obviously everything's running very quick, but it'll be interesting to see the finishes between book data and not book data. And then last tool, which is the chamfer tool.
Yeah.
Again, 150, 150, just gonna leave it. Now the original program was around 21 minutes. Now we're at 20 minutes here, and we've been stopping and starting it.
Yeah.
So that should showcase that we've brought the cycle time down quite a lot. So what's that? 1,700 feed with a chamfer tool, 7,000. Again,
Yeah, you can't hear it really.
can't hear it really. Do you like it when a plan comes together? I was slightly nervous, I'm not going to lie. But watching that, I don't know why I was ever nervous. Just,
Yeah, it'd be interesting to see that, you know, the two finishes.
yeah,
Next to each other. Yeah.
Oh, this is the nervous bit. Oh, when it drops in and chamfers
chamfer's
right
that
in
one,
there.
yeah.
It's so, right.
Oh, clearance is clearance, Tom. So,
Sure, I've read that somewhere. Right, we're done.
it's done.
Oh, are you?
Preparing a tool for you.
Thank you very much.
There you go.
I could have had you as an assistant through the first one. If I put them two side by side and went, which one's which, you would never notice. You would never guess.
Yeah, it's absolutely spot
Check
on
that
the
out.
finish. Brilliant. Yeah, really nice finish. Look at that. Yeah. Yeah. Even on the chamfer.
You
Yeah.
can't even, look, normally if you run your chamfer too fast, you get like loads
Yeah,
of little
yeah,
lines,
but-
don't you?
Yeah, but
Nothing.
No, nothing.
Nothing.
Amazing. Yeah.
Yeah, well impressed. Well impressed with that.
Brilliant.
Well, Kazra, I think if you can give me 5 minutes to get cleaned up, get this swapped over.
Yeah?
I've not just sped the first side up.
Right, okay.
I've
gonna
also
do the
sped the second side up.
Yeah,
so,
yeah.
Right. Kazra, side 2. Do you want to press go?
Yeah? The feed is at 0,
I
so
know,
I'll press go.
I've done that on purpose. Right. Let's just make sure we've got no coolant, if we don't want that.
Yeah.
Oh. Just looking at that spindle speed. Also, I was that nervous, I chewed through my gloves, so I've gone for black gloves this time. I'm gonna mess with this, try and get rid of that.
Sounds slightly better now.
Sounds a bit better, doesn't it? There we go. Sounds alright.
You're increasing the feed.
I am increasing the feed, we're going for it. This is the last one. There you go, 130% and 150% on the spindle load. So
3,700 on your feed on a 16mm cutter.
yeah.
On a pod that is quite thin actually.
Yeah, but we're over 4,000 feet now.
4,000.
Now tell me you've run that at that speed doing that sort of thing.
I haven't, no.
Look at it. Now we've just got to, I'm hoping the middle doesn't flick up. You can hear it going over the centre.
Yeah.
But,
Oh, actually popped out.
there we go, right. 4,300, we've gone for it. We've gone 150, 150.
That last bit
I know, I've got
is
my,
a bit.
I'm waiting for it. I've got my hand. So the only nervous bit now is the last bit. It's coming up. I'm just hoping it just flows it over. So it'll be this cut, I think. There we go.
Yeah.
Beautiful. Goodbye.
Perfect.
But just to get this right, so that was running at 0.1, 150 to start with.
Yeah.
I upped it to 0.2, 180,
Yeah.
and then hit another
150.
50%
On
again.
top of that, yeah.
And then we know, no worries on this tool, we know this will work at 150, 150. We did it on the other side. On a scale of 1 to 10, how nervous were you for that face mill?
I was nervous.
I was at about
was
50.
nervous.
I was at about 15.
50, yeah.
I'm not.
You're taking only like 0.1, 0.2 off that.
Yeah, 0.2.
So, yeah.
0.2, just to finish pass. And again, we'll match it to the first one we did. So it's going to do that, and then it's just going to chamfer everything, just so I don't have to do any bench work.
Yeah.
But yeah, I'm not really
That was
sure.
an experience, that was.
That was an experience from him, and he runs it still all the time.
We don't usually run them dry.
Well, the thing is, that was very, very impressive. That wasn't the best process either, because obviously there was already the drilled holes, there was the centre hole.
Yeah.
Obviously, then we had the end bit, which
Which is falling, yeah.
is falling over. So it wasn't a complete steady process. And it
worked, yeah.
like I said,
I mean, you can spend like days and days to optimize a program, but if you're making 2 or 3,
why
why would you want to waste
Why
your
would you?
time?
Why
Yeah.
not just?
Yeah.
And like, the best thing about that was me when I was stood there and I'm up in it and I could literally see your face at the side of my, oh no, what's he doing?
Well, that's the last one, isn't it?
No, it's just going to chamfer.
The chamfer, yeah,
it's just going to
yeah,
chamfer. And again, I'm leaving the chamfer at 150, 150.
Yeah. Because you can.
Because you can, yeah, and
Yeah.
that's it, because you can. Thing is, if you can run all your tools at 150, 150, you set your machine and you let it go.
Yeah.
Like, what I quite like about this is I've not been having to change the speed and feed on the control per tool, which you do sometimes. Sometimes you can push one tool more than you can push another. But I think I've sort of shown I can push all them tools at the same. Right.
That's it.
Here we go, let's have a look, shall we? Right. If I put both of them, oh wait a minute, cheating here. Right. Side by side,
Yeah.
which is the book data and which is the not so book data? Just on finish alone.
To be honest, they look identical to me. They absolutely look identical. I would say, because we've got a little bit of swarf left in there.
Such a cheater. But yes, you're right. So that was on the right.
But
so
yeah,
that is the one you was
absolutely
just
the
off.
same. I mean, even if you look into like
you
your
look at the
ball
ball.
finish, yeah. Yeah,
There's no difference.
no, absolutely not.
So, one last point from you, Kazra. Looking at what I've just done with them tools, what do you think? Should I be allowed on a machine ever again?
Yes, yeah, absolutely. If you're using Edge, definitely.
Yeah.
Yeah. Well, you proved that you can run it as fast as the machine can take it. Really,
Yeah.
you know.
Well, Kazra, thank you for allowing me to use the machine. Thank you for getting me the tools.
No worries.
I'm just going to go and spend 5 minutes and just have a chat with the audience, tell them what I think of it, tell them what I've done, and really just give them a complete, honest answer. So, Kazra, thank you very
problem.
much.
Yeah,
and I'll see
anytime,
you again
mate. Yeah.
soon. Thank you. So, we finished the two parts. We've got book data and my spicy data. And to be honest, even Kazra could not tell them apart. The finish just looks exactly the same. And the thing is, I've got the tool here, the 16mm, that we punish quite a lot doing processes you wouldn't normally do if you'd had a face mill. And to be honest, it doesn't even look like it's been used. Now, the last time I was at MSC, I was here for the open house where they launched this tool, and I was a bit taken back at what they said it could do. But running it, I think it can actually do more. We pushed this way more than what they thought, and even Kazra's reactions made me laugh because he was getting a bit nervous. So it's definitely opened my eyes to how good this is, and I think people should really start to consider it. I think one of the things to get across is obviously MSC is a distributor, they're not a tooling manufacturer. So you expect tools from tooling manufacturers to be good, but from a distributor, you may not think like that. But I think the difference between MSC and other distributors is this place, they have their own tech center, but also, as you've seen with Kazra and everybody else behind the scenes, they have a lot of actual engineers, a lot of actual machinists. And when I was talking to Kazra about how much I was putting that M-mill through, and he said, oh well, we've done so much extensive testing, he actually showed me in the background how much testing has actually gone into this M-mill. So to make something like this, you've got to have the right team behind it to make it good. And I think that's what really sets MSC and this Edge M-mill apart. They've got the experience of being a distributor, but they've got the expertise of their staff, not only just being engineers, but machinists. They've been on the shop floor, they've seen what their customers need, and they brought it all in and made this.